All right, hello, folks. We are going to go into the last section of this chapter. It is going to be broken into two parts. We are going to do 4.7a right now, and that is about solving radical equations. And we're just going to jump in with some examples. You've done some of this before, but I'm going to assume you haven't done anything. And we're going to go from there. So something like this could be given to you. This is an example of a radical equation where they're asking you to solve. Now, the first thing you got to do here when we are solving is you want to make sure that you isolate the radical. All right. So what that means is get the radical all by itself on one side of the equation. Now, in this case, we've got another term. We got 7 here. We've got to get rid of that. So we're going to subtract 7 from both sides. And when we do that, we get a negative square root of x plus 6 equal to negative 4. Now, to truly isolate the radical, we really should get rid of the negative, but we don't need to if it was something that wasn't nice. Say this was a negative 3 in front, and we didn't want to make an ugly fraction on the other side. Now, I'm one that likes fractions, and I told you to get over fraction phobia, but you can do it as long as it's a single term with a radical without getting rid of that coefficient, all right, or that scalar multiple of the radical. All right, in this case, I'm going to because it's easy enough to multiply everything by -1 and get square root of x plus 6 equals 4. So we've isolated the radical. It's all by itself. The next thing we do is eliminate it. I always say I never realized that the Marine Corps really got me ready for radicals, because in the Marine Corps we used to isolate radicals and eliminate them. So same idea. Anyways, x plus 6 square root equals 4. So how do we get rid of it? Well, if it's a cube root, we cube it. If it's a square root, we square it. If it's a fourth root, we take it to the 4th power. We just get rid of it, whichever way is appropriate for the type of root it is. In this case, it's a square root, so we square each side. And that gives us x plus 6 equals 16. So now we solve. Last step of the process, solve for your variable. So now subtract 6 and x equals 10. Now, there is something about this squaring process in solving that can give us what we call extraneous solutions. Extraneous solutions are ones that we get from using this process, but when we plug them back in, they don't actually work. They are extraneous in the sense that they are not applicable to this problem. So you always have to go back and check. We found that x was equal to 10. So I'm going to go back and say 7 minus the square root of 10 plus 6 equals 3. So 7 minus square root of 16 equals 3. 7 minus 4 equals 3, and that is true. So we get that checked, and we can use that solution. X equals 10. All right, let's move on. Let's do another one. Let's do this one. Another example of solving. So it'll say solve, and 7 equals 3 minus the cube root of x plus 11. So with this, again, I want to isolate the radical, so I'm subtracting 3 from each side, and I get 4 equals negative cube root of x plus 11. And again, I'll probably multiply by a negative, so I get negative 4 equals the cube root of x plus 11. And now we need to eliminate. We've isolated it. We're going to eliminate it by taking to the 3rd power both sides. When I do that, I get negative 64 over here equal to x plus 11. So I need to subtract 11 from each side, and I get 75 equals x. Now again, what do I have to do? I'm sorry, negative 75. I did that. So I got x equals negative 75. I got to go back up here, and I need to check it. All right, so we're going to check this. And we say 7 equals 3 minus the cube root of negative 75 plus 11. And what is that? 7 equals 3 minus the cube root of negative 64. Well, negative 64 does have a nice cube root, right? That's negative 4. So 7 equals 3 minus a negative 4. And that's true. 7 equals 7. So we can go back down here and say that we have verified that x equals negative 75 is a solution. And we can move on. Let's do one more. Let's get a little more difficult here. Let's ramp it up a little bit. Let's see. We got the square root of x plus 1 minus the square root of 2x minus 12 equals 1. Now, this one, obviously, we got a different problem here. We got something that has two radicals. While this process works, we can eliminate one radical at a time by isolating one radical at a time. We isolate one of them, we'll eliminate it. If we have another one left, we then do the same thing again. We isolate that and eliminate it. If we had 4 of them in here, we'd just keep doing the process until we've eliminated each radical. All right, so let's start by, I'm going to isolate this one. I'm going to say x plus 1 equals, by adding this to the other side, I'm going to say this is the square root of 2x minus 12 plus 1. I'm going to add this to both sides. Now, I'm going to eliminate this one by squaring both sides. Square this side, it's x plus 1. Now this, pay attention what's going on here. This is a binomial squared. This is an a plus b squared. What do we do when we have a plus b squared? It's just like saying a plus b times a plus b. And what happens there is we get an a squared, right? The first thing squared. And then we would get plus twice ab, because the middle and outer terms are the same. And then plus b squared. So we can do that here. A squared would be this first piece, this here, squared. Well, that squared is 2x minus 12. And then we have to say we've got a plus in between here, so we're going to have plus next. And then we'd have twice this product of these two. I should do that in another color. It's going to be twice the product of this and this. All right, that times 2. So we would have 2 root 2x minus 12. And then we would get finally this thing squared, so plus 1. And that right there is where people make mistakes, guys. A lot of times we'll see when we get to assessments that people just take this squared plus this squared. Can't do that. You know that's a binomial. That's one quantity plus another quantity, the whole thing squared. So we have to be sure to be careful to follow our rules. So now again, look what's happened. We've kind of, if you look at the overall sentence, we only have one radical left in it. So we want to, I'm going to simplify this first, calling this x plus 1 equals, I've got a 2x, a negative 12 plus 1 is a negative 11 plus 2 root 2x minus 12. So now I want to isolate this radical. So I'm going to add 11 and subtract 2x from each side. So subtract 2x and add 11 to each side. And that will give me, on this side, I'll have a negative x plus 12. And on this side, I'm going to have 2 root 2x minus 12. Now, again, I could divide by 2 here, but dividing this binomial by 2 is ugly, and I don't necessarily want to go there. So I'm just going to, from here, square each side to eliminate the radical. I'm going to consider that isolated enough. Again, remember I mentioned any kind of multiplier there we can leave if we want to, because when I square this times that, I just square both things because they're multiplied, so it works. And so this one, now again, we got a binomial squared, so negative x times negative x is x squared. Negative x times 12 is negative 12x times 2 is negative 24x, and then plus 144, 12 squared. That's how we square a binomial, right? Square the first one, multiply the 2 and double it, square the last one. All right, squaring this would be 4 times 2x minus 12, because it's this squared times this squared. So now I've got x squared minus 24x plus 144 equal to 8x minus 48. And we can move everything to one side, subtracting 8x and adding 48, subtracting 8x and adding 48. We get x squared minus 32x plus, what is that, 192 it looks like? 192 equals 0. All right, now, how do we want to solve this? Well, we could do a couple things. I see that we could use, let's see, completing the square would work pretty well with this because we've got a nice x squared. So why don't we do that? You could also use quadratic formula. Factoring, maybe. Let me just take a, well, I want to demonstrate completing the square. I think 24 and 8 work here, but let's just see. Let's do completing the square. So x squared minus 32x equals negative 192. So half of 32 is 16. 16 squared is 256. Yeah, 256. So plus 256 plus 256. And we get x squared minus 6, I'm sorry, x minus 16 squared, sorry, x minus 16 squared when we factor this sign, equal to 64. That works out nice. Okay, so then we take the square root of both sides, and we get x minus 16 equals plus or minus 8. So x would equal 16 plus or minus 8, which would give us x equal to, well, 16 plus 8 is 24. So we'd have 24, and 16 minus 8 is 8. So we get 8. And we've got these two solutions. Now, what do we have to do? Got to check them. So 24 and 8. Let's go back to our original statement here. And in fact, there's no room. I'm just going to do it down here. Let's check down here. All right, so checking for 24. And we have the square root of x plus 1 minus the square root of 2x minus 12 equals 1. And we're going to plug in 24. So we're going to get the square root of 25 minus the square root of twice 24 is 48 minus 12 is 36 equals 1. So that's 5 minus 6 equal to 1. That is not true. 5 minus 6 is negative 1, which is not equal to 1. So 24 does not work. We can cancel that. We did get an extraneous solution there. And if 8 doesn't work, we just write that there's no solution to this. But we got to check 8 first. So plugging 8 in, we'd get the square root of 9 minus 2 times 9, or 2 times 8 is 16, minus 12 is 4, equals 1. So 3 minus 2 equals 1. Now be careful when you're reading these. I had the negative square root, so I put negative 2. I had negative square root, so I put negative 6. Don't try to think it's plus or minus. It's exactly what it says it is. So this is 1 equals 1. This checks. And 8 is a solution. That's what we're doing, guys. It's simple as that. We're going to be working with solving radical equations. So have at it, and we'll answer your questions tomorrow. Have a great day.